Good afternoon, everyone. So, can you hear me?
Yes.
Okay, good. You can, if you have any questions, you can unmute yourself and ask me. Also, you can use the chat window. So, I'm going to share my screen. So, this experiment, usually it takes 2 weeks, but because of the COVID, we are going to do in 1 week. So you need to listen carefully how we are going to complete the first half tonight before you do the actual lab. So what is the actual lab? Investigation 2 is about stoichiometry. Okay? And you're going to solve a real world problem which is you are given. You are given a real world problem. What are the products of a chemical reaction? If I do a reaction, A reacts with B to produce some product. We don't know. It could be more than one product. So you must know the left side you have reactants and the right side you have the product. Okay. There are many reactions. These are called redox reactions. The reactions can be divided into many different groups. One of them is called redox. That means it involves reduction and oxidation. Okay? You'll be learning in details in 1150. And the balancing redox equation sometimes difficult if I use the half reaction. Okay? But I'm going to simplify everything. You will see everything makes sense. So whenever you have a redox reaction, you can have more than one possible chemical equations because of the more than one possible products. So I can react A and B together. I can get P2 plus D2, something like that. So I can have one reaction like this, another reaction like this. But you are going to do one reaction. You're going to figure out what is the actual chemical equation. Okay, so I repeat that one. You are not going to do two different reactions. This is a common mistake. You're going to repeat the reaction for some other reasons. But you will be doing one reaction. And your goal is to figure out what is the actual chemical equation for that reaction if I have more than one possibility. And again, this is just the end result. I'm telling you what is your goal. And now I'm going to show you step by step how we're going to achieve the goal. Okay? So, before I do the actual experiment, I have to understand some of the terminologies. Like, what is stoichiometry? What is limiting reactant? What is theoretical yield? What is percent yield? Okay? Otherwise, I won't be able to solve this kind of problem because this is a hard problem. You do a chemical reaction, that means you mix two reactants together and something happened. You got a product. Your goal is to figure out what are the product. Okay? That means your goal is to figure out what is the chemical equation. Okay, you don't have any control about which equation you're going to use for which reaction. No, the reactions are going to go on their own. Okay, but you are going to use experimental data to figure out what is actually happening in the molecular level, in the chemical level. Okay, so first you got to understand the limiting reactant. Using a reaction, and it's called balloon race. Well, it's a balloon race. I mean, you can give it any name, but basically you are mixing two chemicals together. Here there are two chemicals, and there is a product which is carbon dioxide. Based on the amount of the carbon dioxide, you are going to figure out which one is limiting. So that brings the question, what is the definition of limiting? Have you learned in 1150? I'm sure you have learned. Okay, so we're going to apply this. And this is very helpful if you understand what is limiting and how do you figure out the limiting reactant. So again, you are not going to do this tomorrow. This experiment has been done and we recorded a video and posted on Canvas. So you need to watch and figure out how do you interpret the data. Okay, so the first part that you're going to do today, you're going to complete. The second part you're going to do tomorrow. So how it is done? You are going to use acetic acid, which is a component in the vinegar, and sodium bicarbonate. Okay, so you have fixed amount of the acetic acid, fixed amount of acetic acid into each beaker, and you need to watch. I'm assuming you watched the video. And fixed amount, what is the amount? 25 milliliter. Then you're going to take different amount of sodium bicarbonate. Again, you are not going to do the experiment. It has been done. You are going to write what the observations based on what you have seen in the video. So we are going to vary the amount of the sodium bicarbonate. And in a chemical reaction, you see this is nothing means 1, 1, 1, 1. These are called mole ratio. So the ratio means 1 to 1, this reaction. These reactions occur at a ratio 1 to 1, and that is fixed. You cannot change this. Very, very important. Because the molecules react by their own, and when they react by the number, which is mole. And I repeat, molecules do not react by their mass. Molecules react by the number, which is mole. That you can find out from a chemical equation if it is balanced. But in the real world, we go by the grams. That is where difficulty comes. So we need to know how do you convert from grams to mole. Then I can answer this type of questions. So I know that 1 mole reacts with 1 mole. These two reactant. I'm going to keep this one fixed, which is 25 milliliter. And we'll figure out 25 milliliter means how many moles. That we are going to keep is as constant. We're going to vary this one. So we have to figure out how many moles we are adding. That is the moles here. How many moles you are adding. Okay. That is variable. And then you see what happens after the reaction. So that is your goal. So you added 25 milliliter of acetic acid. Plus you had an indicator, HIN. 25 of acetic acid plus indicator. Again 25 acetic acid plus indicator. 25 milliliter acetic acid plus indicator, HIN, plus indicator. And you had the sodium bicarbonate in the balloon. NaHCO3. NaHCO3. Remember, at the beginning you had the solid, but when you put upside down, then all the sodium carbonate dropped here into the flask. Again, if you watch the video, you understand what I am saying. So then you're going to see bubble formation. We call effervescence. That means one of the product is gas. And we know the gas has a tendency to escape because of the kinetic molecular theory, which we'll be learning again 1150. So then you're going to calculate how much carbon dioxide we got from each one. Okay, we don't have any sodium bicarbonate anymore because it's went into the flask. So no sodium, only the carbon dioxide. You see the balloons, different sizes here because of the different amount of the carbon dioxide. Okay, so you need to answer the question here. That is your goal today. Okay, and then I'm going to go to the next part, which you'll be doing in the lab tomorrow. So the first thing, you have to complete this form, fillable form. You can download and then. So again, as I said, the amount of the acid is constant, which is equivalent to this many moles. You do not have to do. We already did the calculation for you. But what you have to do, you have to complete this. How many moles? So can anyone tell? If I have 0.7, if I have 0.700 grams of sodium bicarbonate, how many moles? So then you need to know mole equals grams over molar mass. And what is the molar mass? You are giving 84.0. So what will be the answer? If I use my calculator, the answer is going to be, again, so you're going to use significant figure rule. I didn't deduct any point on the first experiment, but I think I would say 50% of what you were correct on the significant figure, but more than around 50% student didn't do correct on the significant figure. So you must know the rules. So what are the rules for division? How many significant figure you have here? 0.700. How many? 3. How many you have here? 84.0. How many? 3. So the answer should have 3. So if I use my calculator, I may get too many significant, but I have to know that I have to write the answer with 3 significant figure. That means I have to use 3 digit. At the beginning, all the zeros after decimal place, they are not significant. Okay, so this one has 3 significant figures. This many moles. If I do the next one, again I'm going to write with correct number of significant figure. Calculator is going to give you too many. You don't want to write 3 significant figure. The next one is going to be 0.025. Next one is going to be 0.0500. I need to have 2 zeros to keep the significant figure number 3. And the next one is going to be 0.0750. So notice here, equation had 1-to-1 ratio. So what was the equation? Equation was vinegar, which is this. Now in your lab manual it is written in different ways. It can be read in many different ways. So this is the vinegar, which is acetic acid, plus sodium bicarbonate to make carbon dioxide plus water plus sodium salt of the acetate, so which is Na CH3 C double O minus. So I can write CH3 C double O. Okay, so that means you have salt means cation plus anion, and you see the mole ratio is 1. All are 1. These are the two I'm looking at because I'm adding only these two. So what is the mole ratio here? Which one is greater, this or this? Okay, so I think this is the time you need to say something, otherwise I don't know whether you are understanding the concept or not. So I'm going to help you to fill it out. It says color of the solution. What is the color of the solution you see?
Red.
Red, very good. So I'm going to write red. Then it says balloon size, small, medium or large. You see, so this is going to be small. So I'm going to write small. Do you see any solid left? Any residue left? Yes or no?
No.
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 What reactant is the limiting? Then you need to compare these two numbers. So what is the definition of limiting? Limiting reactant is the reactant that runs out first. That means I'm going to compare 1-to-1. If I have less than 1, that is going to be limiting. Now any number, 1 is an example. I have 2 required, but if I have less than 2, then it's going to be limiting. So you are comparing these two numbers. What are the two numbers? Here 1. What do you see here? 0.025. And here what do you see? 0.00833. Which one is smaller? Sodium bicarbonate.
00833.
So that means sodium bicarbonate. So what is the limiting? I'm going to write sodium bicarbonate. Because I didn't have enough sodium bicarbonate. So all the reactants have been used up. So the amount of the product, carbon dioxide, which you're going to monitor, is the smallest. Because it produces only little carbon dioxide compared to others. Now the next one. 0.250 and 0.19. You will compare these two. This and this. Which is smaller? This or that? Again, this is acetic acid. This is sodium bicarbonate. Which one is smaller?
Sodium bicarbonate.
So that would be limiting. So I'm going to write here, next one. Sodium bicarbonate. What is the size? I'm going to write medium. Do you see any leftover solid? No. What is the color? Still red. Now that is very important, I'm going to tell you. Because I mentioned the indicator. The color of the indicator will tell you whether the solution is acidic or basic. That means you have more acid, which is vinegar, or more base, which is sodium bicarbonate. So you can see, because the sodium bicarbonate is limiting, we do not have enough. That's why these are red, acidic. The first two. The second one, and third one. Now I'm going to compare the third one. Third one you see here. What is the color?
Dim.
Very dim. It is kind of yellow. Okay, so I'm going to see yellow. What is the size? If you compare these three, I would say all are large.
It's large.
Yeah. So which one is, do you see any leftover solid here? On the third one? Do you see?
No.
No leftover. So what will be the limiting? Then I have to compare these two numbers. 0.0250, 0.025. Again, you need to have a 0 here. Which one is smaller? Again, in order to be limiting, one has to be less than stoichiometric amount. If you have exactly the stoichiometric amount, none of them are limiting. So I have the same amount. So what is limiting?
Neither.
Neither. Very good. Neither. Because you have stoichiometric amount, exactly the same amount you needed for the reaction, 1 to 1. Mole ratio is 1 to 1. So if I do 0.025, 0.0250 divided by 0.0250 is 1 to 1. Okay? Very important. So, next one. If I go to the next one. Number 4. If I look at the number 4, this is number 4. What is the color?
White.
White is not a color, so I'm going to write colorless. Like, I know this is a common mistake. What is the color of the water? Colorless. Okay? No color. White, you'll see, that means like snow is white, but water is colorless. Okay? And you need to, if you take physics class or maybe in chemistry class also, we explain why. Water is colorless, but snow is white. Why? But again, that is not our goal. But you need to be curious to know about anything new. When you learn, then you need to be curious why. And that's how you learn more and you have better grade. So, if I want to write the size, again, I'm going to write large. Are there any solid left?
Yes.
Yes. You see that these two, they have solid left. So, yes. So, what would be the limiting? So, I'm going to compare these two. 0.0250, which is constant in every flask. But I have here double amount of sodium bicarbonate. So if I want to know which one is limiting, the other one needs to be excess. So I see sodium bicarbonate is excess. So what is limiting? The acetic acid is the limiting. So excess is going to be opposite. This one is going to be excess. These two are going to be the opposite. So this is going to be excess. You have excess acid. And this is going to be neither. And this is going to be NaHCO3. Notice these two column. The first one, it says what reagent was limiting. So the other column says what reagent was in excess. So these two are opposite. But because this is neither, so that has to be neither as well. Because both the reagents you added are the same amount, stoichiometric amount, 1 to 1. If I do the last one, do you see any leftover? Yes, so last one, number 4 and 5 is going to be the same. So this experiment is going to give you an idea. So again, number 4 and 5 is going to be the same. So did you predict that based on the amount of the sodium bicarbonate, this is going to be the largest? Most of the students predict, oh, this is going to be the largest. Why? Because I have more sodium bicarbonate. But no, in theory, all the three should have the same amount of product, carbon dioxide, which you can see because the experimental error, this seems a little bit larger, and that can be justified using a principle that is called Le principle, which unfortunately you're going to learn in 1160. So the chemistry, that is the difficult part in chemistry. Sometimes if you want to go a little bit deeper, you require more knowledge, which you're going to learn later. Okay? So based on the knowledge you learned so far about the limiting, if I increase one of the reactant, like here, after the mole ratio 1 to 1, if I have this one is limiting, doesn't matter how much sodium bicarbonate I add. I can add 1 more gram into the reaction mixture, but the amount of the carbon dioxide is going to be the same. Okay, so that is the main goal of this experiment, to figure out that irrespective of the amount of the sodium bicarbonate, if this is limiting, doesn't matter how much you have, excess you have, still you will have the same amount, and that is proven from the size of the balloons. So they're going to be the same size. Okay. Then you're going to answer this question. In which plus was the smallest amount of the product? You know this is the one. What is the evidence? So evidence, you had smallest amount of the sodium bicarbonate, which is limiting. What is the limiting reactant in the flask with the smallest balloon? Again, what is the answer? Vinegar. Oh, sorry, sodium bicarbonate. Evidence. Smallest amount of the... But when you compare, you need to compare with the mole, because in chemistry, you cannot tell anything with the grams. And I'm going to explain in the next slide. Whenever you are given a grams, you don't know how much you have, because the molecules react by the sizes, not by their masses. You have to go to the mole, which means you need to divide by the molar mass. In which plus was the largest amount of the gas produced? So these will vary depending on the experiment. Sometimes we have experimental error, and that's you may not get this one as big as this one. Okay, so you justify based on what you saw in the video. Again, you are not going to do the experiment. This has been done for you. Your goal is to watch the video and explain these questions based on your observations from the video. How do you write all these answers? So what is the evidence? I would expect that these three would have the same amount of the carbon dioxide. So at the end, you're going to write what is, based on your observation, what is the limiting reagent. So limiting reagent again is the reactant or reagent that runs out first. That reagent will determine what will be the actual amount of the product, which is extremely important for 1150. So if I am given 2 different amount of the reactants, I have to figure out which one is going to run out first. Then I can figure out how much product I'm going to get and which is going to give the smallest amount of the product. Okay, tell me if you have any questions. So this is the pre-lab. You need to complete these 2 by tonight, and then you are done the pre-lab. Then I'm going to go over how we're going to do the actual lab. Okay? Have you watched the other videos? the proposal video. I know some of you watched.
Yes.
Okay. Do you have any question on the pre-lab? So this is the pre-lab. You need to complete it. If you don't, yes, go ahead.
So when it was talking about the smallest amount of gas
Right.
produced,
Mhm.
and you said that would be based off of the moles.
Moles
And
of
not-
the reactants, yes.
Okay.
The limiting reactant, which is sodium bicarbonate, and the first one has the smallest amount. Okay.
Okay.
The gas is an example, but in the 1150 we'll be doing many more example that may not be the gas, something else. Okay. But once I understand the concept, any product, if you want to figure out the amount of the product, you can use the limiting reagent concept, which you're going to do next. Okay. So this is going to give you which one is the smallest, which one is the largest, and why. Now you gain some knowledge about stoichiometry, which is molecular calculations involving chemical equations. And you learn the limiting reagent is the chemical or reactant that will dictate, very important, that will dictate how much product you're going to get. If I change the limiting reactant, the amount of the product will change. If the limiting reactant is constant and you change the other reactant's amount, you will not have any different amount of the product. And I will repeat this one again. So, we're done. Okay, I'll be happy to answer any questions on the limiting reactant, balloon race, if you have anything. But I thought it was straightforward. I understand this is the first time you are learning probably, and so you might have some questions. Now your goal is to how to apply this limiting reagent concept in a real world example to solve a real world problem. So you are giving a real world problem. What are the products of a chemical reactions? If I use two chemicals, copper sulfate plus iron, what are the products? You can have FeSO4 plus copper, or I can have Fe2SO4 plus copper. So this is called iron 2 sulfate. This is called iron 3 sulfate. If you don't understand, please go back and watch the video. It has been explained there. Oxidation number. So how do I know if I do a reaction, if I mix these two together, how do I know that I'm getting iron 2 sulfate plus copper or iron 3 sulfate plus copper? So that is a real world problem. Again, when you do a chemical reactions, you don't have it in control that you're going to make iron 2 or iron 3. Reactions are going to go based on the energy level in the molecule or in the reactant, which you are going to learn, I believe, chapter 6 and 7. But not yet. Okay. So right now you need to know that you don't have any control. You mix the reactants together and then you get some product. Based on the amount of the product, you're going to figure out which chemical equation is correct. If you are given two equations, you may have more than two. There are reactions. You may have more than two possibilities. Okay. So here you are giving two possibilities. So how are we going to do? So you'll be working, because of the COVID, you are going to do work individually, but you're going to partner with the another one which is nearest to you. Okay, and I'm going to explain. You will be doing one experiment So you're going to take one beaker, you're going to take copper sulfate, and then you do the reaction. And then another student also will do exactly the same thing. In other words, you are going to repeat the reaction twice for comparison purposes. You are not doing two reactions. You are doing only one reaction. Everybody will do the same reaction. So after the reaction, you're going to figure out. Now more time you repeat, you'll have better results. But we don't have time. So that's why we're going to combine two student data together to make a conclusion. What are the products of that reaction you just did? Okay. Don't think that if you are student A and another student is B, this is the common mistake. Some students think, oh, I'm doing one reaction and my partner is doing another reaction. No. All you are doing the same reaction. You don't have any control. You are following exactly the same procedure. You are taking same amount of the reactants, and then you are going to recover them, one of the product, to figure out which chemical equation is the correct. So you're going to follow the very, very important clean up and the checkout, and that has been posted in the lab. I'll go over again tomorrow. Okay. Then, because you are going to weigh out the amount of the product, copper, you need to dry in an oven. So, which is going to take about 35 minutes to dry. Okay, and I'm going to go over again. Then once I know the mass of the recovered copper, then I can go back to know which reaction occurred. Reaction 1 or reaction 2. Because the mole ratios are going to be different, which I'm going to show in the next slide. You are going to decant. So once you have the copper here, you're going to decant. So have you watched the decantation video? What is the meaning of the term decant? Anyone? Again, in chemistry we use many different terminologies. Decant means to remove the unwanted, leftover or unwanted reactants and product. We want only the copper. So all the solution you are going to pour in a beaker using a glass rod, and that process is called decantation. So again, you must watch the video before you come to the lab. Because of the COVID, usually I show in the lab, but we need to we'll try to minimize the lab time, and that's why I'm doing before the lab, to make sure that you understand. This is one of the most difficult lab because of some of the misconceptions. So make sure you understand, and I'm going to clarify. If you have any questions, I'm going to clarify. Today is the time before you come to the lab. Make sure you know what you will be doing, how you will be doing, and then next part is going to be a little bit difficult, which I'm going to explain why you are doing all these things, because you have to write a lab report, formal lab report for this. So you must watch what is decantation. That means to recover the copper and to get rid of the unwanted leftover reactants and the unwanted products. So how are we going to do it? You're going to write the procedure in the proposal. So again, if you watch the video, you know how to write it. You're going to take a 25 milliliter beaker. Don't take too large. And you know the mass of the beaker. You have to know the mass of the beaker. Common mistake. If you do not know the mass of the beaker, you are not going to know the mass of the product. So before you start anything, you need to weigh out the beaker using a balance. Okay. Then you're going to take 8 grams copper sulfate. Okay, and I'm going to explain why 8 gram. Again, if you have watched the video, you should know why 8 gram. I'm going to transfer. I can weigh out directly into the beaker or I can transfer here. Doesn't matter. But you don't want to lose too much. But anyway, this is not going to be limiting. This is going to be excess. Can anyone explain? So what is the limiting? Limiting is going to be iron filing. I have to dissolve the copper sulfate in water. So how much water are you going to add? You are giving all the information. You are giving the solubility. So you can calculate. And I'm going to tell you because again, for some reason, sometimes you overlook. Okay. So you're going to use around 25 milliliter. Not more than 30 milliliter. You do not have to measure out exactly because that is not the limiting. The solvent is not the limiting. But you need to add reasonable amount. Okay. Reasonable amount is 22, 24, 25, 26, any. You do not have to spend too much time to measure exactly. Okay. Then you're going to use a hot plate. Now, hot plate is just to warm, to heat up a little bit. You can do at room temperature, but the reaction is a little bit slow at room temperature. The reaction is complete in less than 5 minutes. If you do the reaction between 50 and 70 degrees Celsius. So how do you know the 50 and 70? Again, depending on your experience. I never used, to know 50 and 70, I never used thermometer. But you will be provided a thermometer. Because I have experience. By knowing or touching a little bit, I can feel what will be the temperature. Based on my experience. But you will be provided a thermometer. You can put a thermometer inside and record. When it is above 50, you turn off. So there is a setup. And you have the setup is like here. So you have 1, 2, 3, 4, 5, 6, 7, 8 and so on. I would start, maybe I'm going to set it at 3 first. Okay. And wait 1 or 2 minutes. And I'm not going to touch. I put my finger close to this and I will feel the heat. If I don't feel heat, then I'm going to turn up a little bit more to 4. Otherwise 3 should be enough. And then you turn off. Turn off to 0. 0 should be here. Turn off to 0. Then what are you going to do? You're going to add the iron filling. Okay? All the iron filling you need to add. You need to add at once. That means all together. Okay? What are you going to see? You're going to see the iron filling is going to make some reaction. And then at the bottom, you're going to see like this. Okay? This is what you're going to see. So once I see this, I'm going to turn it off, everything, and I'm going to use a tongs. Does anyone know what is the meaning of the term tongs? I'm going to use a tong, beaker tong. So we're going to have a mess. You're going to see this is wire. You're going to put the beaker on the top of the wire. Why? Because you don't want to burn the countertop. Okay? Let it settle for 3-4 minutes. And what I'm going to see? You're going to see like this. You're going to see like this. With some solution. Then you have to do the decantation. The blue solution should be there. Blue solution should be there. But after decantation, the blue was there. I'm going to put the blue color here. Blue color was there. But you remove the blue color. by decanting. So that's why I need to watch the video. Then you have the copper. Now this is a little bit darker copper. It's taken from one student's beaker. But you can have very shiny copper. What is the color of copper? Metallic copper. You know the metallic copper means? Is it brown? So the brown metallic copper. You're going to collect. You need to wash with water again and decant couple of times because you don't want any unwanted blue color there. If you have some blue color, that means it is not going to be shiny and the amount of the product is going to be more than what it's supposed to be. As a result, you cannot make any conclusion. So it is very important that you wash a couple of times, and then finally you're going to wash with acetone. What is acetone? We're going to provide you. It's an organic solvent, and the commercial name is called nail polish remover. So what is the purpose here? The purpose is to get rid of the water because acetone is polar, so it can take the water away and you can dry the copper very quickly when I put it in the oven. Even sometimes you don't put it in the oven, if you leave it outside for an hour, it will be dry. Otherwise, it's going to take longer time to dry. You have to have a dry copper. Then I know how many grams I have, and in turn I know which reaction took place. Okay, so how do you figure out which reaction took place? So again, if you watch the hypothesis video, you know how to complete the hypothesis. So these are the two reactions, possible reaction, hypothesis 1 and hypothesis 2. Now tell me the first one, is it balanced? I have one copper. I have one iron. I have one sulfate. So yes, this is balanced. So it's 1 to 1. Nothing means 1. Okay. How about the second one? Is it balanced? No, I have 2 here, so I need to put 2 here. I have 3 sulfate, I need to put 3 sulfate here. So if I put 3 sulfate, I need to have 3 copper. Okay. So what is the mole ratio here? Mole ratio is 1 to 1. 1 to 1. What is the mole ratio here? Here I have 3 to 1. 3 to 1. If the mole ratios are different, the amount of the product is going to be different. And if I know the amount of the product, I know which reaction is true. Okay? There are many other ways you can tell, but that is going to be difficult for you. And you haven't yet probably learned the other things. But you are using, and that's what you need to explain, why you are using stoichiometry. Is this the only way to figure out? No. This is one of the many different ways you can figure out which one is the correct chemical equation happening here. Okay? So, based on the amount of the product, let's try the first one. You are going to start with always grams. And in chemistry, you cannot do anything with grams. So you have to go to the mole. Because mole is the number. And the number tells you which one you have more, which one you have less. Which one is limiting, which one is not limiting. And how much product you're going to get from the chemical equation. So the mole will go to the another mole based on the chemical equation. So the first mole is the mole of the reactant. The second mole is the mole of the product. Then I'm going to go to the grams of the product. Now tell me, if you have watched the video, you need to tell, some of you at least, which one is the limiting here and why? Anyone? If I use this one limiting, do you think I can solve the problem? Yes or no? No. Why? Because if this is limiting, then this is going to be excess, which is a solid. And the product, this is also solid. You're going to get a mixture. You cannot identify or cannot get the pure product. As a result, you cannot use that amount to make a conclusion which reaction is occurring or happening. You cannot. So in order to get a pure solid, I must have this one is limiting. Otherwise, I cannot do this experiment. So this is going to be excess, and this is going to be limiting. Iron has to be limiting because this is solid and this is solid. Okay. Can someone say what is the color of iron filings? What is the color of iron? Anyone? I cannot see the chat window, so you have to say. If you are typing for some reason, because I'm using the PowerPoint, so that is hidden. I'm sorry about it. Tell me, anyone, what is the color of iron? Just say something. Doesn't matter whether you learn from. We all learn from mistakes.
Brown.
Okay. Anyone else?
Silver.
Very good. The color of iron is silver. But have you seen any iron silver? No, you don't see. You can see if you cut, then you're going to see temporarily inside silver. But then it will turn into brown or black. Why? Oxidation, aerial oxidation. Okay. So iron filing, so that is a very good point, because when you write the lab report, you're going to justify. That means you have to know the possible sources of error. So you know right now, I'm going to give you a clue and I will explain again tomorrow. Because the iron filing, what you will see tomorrow, like blackish brown, that means that may not be 100% pure, maybe 95%. Okay, so that's one of the possible sources of error. Okay, so have you understood the iron, why iron needs to be limiting? I'll be happy to explain. This is very important, key concept here. Why iron got to be limiting here? Otherwise, you cannot solve the problem. Anyone?
Because it's a solid.
Because it's a solid, and you don't want to contaminate the product which is solid. So, I cannot use the copper sulfate, which you're going to take 8 grams. But you're going to take 1.100 grams iron, which is limiting. And we learn the amount of the product can be calculated in any chemical reaction if I know the amount of the limiting. That's what you learn from the balloon race. So I'm going to start with 1.100 gram iron. And I also teach 1150, but this semester I'm teaching 1130. So next block I'll be teaching 1150. Okay? And I show my students how to solve this kind of mathematical problem from scratch. As if you don't know. First you have to figure out where do you start. So start what you are giving. Right on your left. And what you are looking for. the grams of copper. That is your goal. So you have a destination. You have a destination. You go from there, here to there. And what is the route? This is the only route you can take. Grams to mole. From grams to mole. Then mole, then grams. Okay, don't forget. If you practice, you will see this is very easy. So I know grams of the iron. I have to cancel out the grams of the iron. So the grams of the iron has to be on the bottom. What has to be on the top? The mole of the iron. Then I have to cancel out the moles of the iron. So moles of the iron has to be on the bottom. What has to be on the top? Moles of the copper. Because that's your goal. But you don't want moles, you want the amount in grams. So the moles of the copper can be cancelled out. If I put on the bottom, on the next conversion factor, and the grams of the copper has to be on the top. Then I have everything cancel out, this cancel out, this cancel out, this cancel out. I have grams of copper, which I'm looking for. Okay. Then you need to plug in. So what information do you need? You need the molar mass. 1 mole of iron equals how many grams? So 55.85 grams. And the mole ratio. If I use the first one, mole ratio 1 to 1. 1 and 1. So this is going to be 1 mole copper produced from 1 mole of iron. And 1 mole of copper means how many grams? 63.55. If I do the math, so I have just done for you, and that is going to be 1.252 grams of copper. So if I get close to 1.252 grams, less than, then the reaction 1 is valid. That's right. Why you cannot? Can you have more than 1.252 grams? No. Why not? Because of law of conservation of mass. You cannot get more than what you had. Okay? Mass needs to be conserved. Okay? So how do I know what is the maximum amount I can get from this equation? 1.252. That is called theoretical yield. Theoretical yield. 1.252. You cannot get more than 100% yield. That is impossible. That is against the law of conservation of mass. Okay. Now if I use the equation 2, this is the equation 2, hypothesis 2. Everything should be the same, only the mole ratio is different. 2 moles iron here reacts to make 3 moles of copper. And 3 by 2 means what? 3 by 2 means 1.5 times moles. So I don't have to do all the calculation, I can multiply by 1.5. It's 1.252. Now I can, this is I simplify, but I will be happy to explain different ways. So if I do multiply by 1.5, the answer is going to be, let's see if I have here, 1.878. I'll be happy to explain. I just simplified because only the difference he has 3 and 2, which is 1.5. So if I multiply this one by 1.5, I can get the amount for the equation 2. So if you get more than 1.252 grams and less than this amount, you know the equation 1 cannot be valid. Equation 2 must have took place. This is how, using stoichiometric calculation, you can figure out which equation is valid. You did mix together two chemicals. You collected the amount of the product. Based on the amount of the product, you know which equation happening in this reaction mixture. Okay? So that is your goal. So I just showed you the calculation. Then what are you going to do? So again, you need to watch the hypothesis, the proposal, for hypothesis 1 and hypothesis 2, and it is clearly mentioned how you're going to complete the proposal, which you need to write on your lab manual, because that is the one you're going to bring tomorrow. You don't have to turn in anything. Okay? So what are you going to write? You're going to write the procedure. You're going to write the procedure, how you're going to do, and you're going to write when the hypothesis 1 could be valid based on the amount of the copper recovered. If the amount of the copper recovered is less than 1.252 gram, then hypothesis 1 is valid. If the amount of the copper recovered is more than 1.252 but less than 1.878 gram, then the hypothesis 2 is valid. Okay? Now, whatever I just said, that is based on the knowledge you gained from the stoichiometry or limiting reagent. That is not based on your actual experience in the lab, okay, which is going to be a little bit different, okay, and you have to think hard why. So what do you have to do in the lab? You are going to, first you're going to complete the experiment, which is going to take 30 minutes, and then you're going to put, so you have the beaker, you need to know the mass of the beaker, and then you need to know the mass of the beaker plus the copper at the end of the experiment. So if this is the mass of the beaker, that you must, and this is the mass of the beaker plus recovered copper. So if I subtract this one, so this minus this is going to give you the mass of the, so actually this one, I should write, this is number 1, this is number 2. So 1 minus 2 was going to give you the mass of the copper, okay, which is going to be, again, 1 gram, 2 gram, depending on how do you do the experiment. Then you're going to calculate, you need to show, which I already did, theoretical yield. Theoretical yield from equation 1. So theoretical yield based on the equation 1 is going to be 1.252 grams. Theoretical yield based on the equation 2 is going to be 1.878 gram. Okay. Then you're going to write percent yield. Percent yield. Okay. Percent yield. So if I get percent yield equals what? Is the actual yield, which you're going to know tomorrow, actual amount divided by theoretical amount times 100. That is going to give you the percent yield. Okay, so you're going to do for both, and then you're going to compare. So if you get less than 100%, that means that equation is valid. If it is more than 100%, that equation is not valid. Okay. Now what if both the equations give you less than 100%? Then how do you know which one is correct? So first you do the experiment, and then you complete the calculation, and you see the percent yield. Percent yield based on the equation 1 and based on the equation 2. What are the numbers you are getting? Lot of math you're going to do tomorrow. Okay, I'll be happy to explain tomorrow again. So in other words, you're going to have 4% yield because you're going to repeat the experiment, and then you're going to have this percent is going to be based on the equation. So you're going to have based on hypothesis 1, hypo 1, and also you have based on hypothesis 2. Why? Because these two are going to be different. Theoretical amount will come from the hypothesis 1 or hypothesis 2. So this is going to be fixed because you just completed the experiment and you know how much you recovered. You cannot change that number. But this number will change based on the hypothesis. So for the hypothesis 1 is going to be 1.252. For hypothesis 2 is going to be 1.878. Then we'll get the percent. And we'll see what are the percentages we get. Okay? Any question? I know too much math involved here. But it will be fine. Believe me. That's why it is very important that you spend some time and think about it. What are the reasons behind the experiment? What are the goals? And how we're going to do it? And then if I know everything, then I know how to write it, which is going to be another difficult part. If you need my help, I'll be happy to do another WebEx tomorrow or day after tomorrow, because that is going to be due on Wednesday. Okay? So, how we're going to write? So first, before that, you're going to have some discussion. Again, discussion, you're going to write a guiding question. What are the products of a reaction? If you do the reaction, copper sulfate with iron, are you going to get iron 2 sulfate with copper or iron 3 sulfate with copper? That is the guiding question. And then you're going to make a claim based on the percent yield. Again, this has to be based on the percent yield. However, in the proposal, you wrote based on the grams, which are similar but a little bit different, because percent yield is going to give you a little bit more in-depth analysis. I understand that. That at the beginning you didn't have about all the knowledge, so you just wrote the amount of the product is going to guide you which reaction is happening. But we are going to convert the amount to the percent because I know the theoretical yield. So the actual yield divided by theoretical times 100 is going to give you the percent. Basically the same thing. Then we're going to write what is your argument. What are the evidence? Evidence will come from the data. And the hardest part is justification. That means why percent yield? Why not something else? Why did you use limiting reagent to justify? Okay. I'm going to give you, if you want, I can give you some heads up how we're going to write. Do you want me to go over a little bit? Because it's already, about an hour. I can show you, these are the questions. Any questions? So basically you need to answer these questions. Okay, so this came from the hypothesis. But you need to know, before come to the lab, how do you get the percent yield? I already showed you. What is theoretical yield? I showed you. From the limiting reactant, how do you get the theoretical yield? Okay? And then how do you write the lab report, which is the, don't worry, I've been teaching again many years. I want to make sure that you understood before you leave the lab tomorrow. I'll go over with the main points, how we're going to write the lab report. I can go over right now, but you may not be able to grasp because you need to do the lab. Once you have the hands-on experience, then it's going to click your brain to understand why you're doing it. and how the amount comes from the limiting reactant. Why not something else? Why limiting reactant is so critical to solve some real world problems like this. When you do chemical reactions, there are many possibilities. But how do you figure out which one is actually happening? Because the molecules are very tiny. We cannot see them. But we can see or figure out through the knowledge we gained from the stoichiometry. You can imagine that yes, you can see how the molecules are combined, how the ions are combined together, or how the molecules are formed on the product side, how the molecules are broken down on the reactant side, which eventually you have to get some visualization at the end of 1150 course. Okay, later on we'll be learning. I mean, reactions are everywhere. Okay, but how do you figure out what is happening in a chemical reactions? Okay, so I'll go over. I'm not going to take too much time today. Tomorrow I'm going to go over. First, I'm going to take few minutes about the safety, and then after you are done with the calculations, I will help you to interpret the data, and then I'm going to go over on this slide how we're going to write the actual lab report. By the way, we'll have plenty of opportunities to improve. So first you're going to write a draft based on the input tomorrow you're going to get. Once you write a draft that is due on Wednesday, then it will be peer reviewed. That means it will be reviewed by 2 of your classmates, and I'm going to assign through the Canvas. Once you get the assignment on Wednesday night, Thursday night you need to review. So everybody is going to review 2 others, lab mates writing, and you are going to grade as a teacher to see if you can grade them and put some feedback. Then Thursday you are going to get all the feedbacks, and Friday, I believe, no, by Monday you have to revise, you rewrite the lab report based on the feedback you received from the peers. Okay, and then you're going to submit. Then I'm going to grade the final one. So in other words, there will be many opportunities to correct. If you get wrong on something, it should be corrected by the peers. And also, when you review 2 other lab reports, you know how other students are writing. And then you will think, oh my goodness, I could do like the same way. I could present. Okay? So this is all about learning. So at the end, I hope most of you are going to have very good grade on the, this is going to give you, I think, more than 100 points, this investigation. So you need to be serious. I'm here to help you, but you need to ask for help. Again, first you write, and if it is necessary, I'm going to go over again on Wednesday maybe. But tomorrow probably I'm going to explain everything. I hope you do not need any help. But if you need, if you need help, I'm here always. Okay. Do you have any questions? If you don't have any other questions, so that's all for today. So I'll see you tomorrow in the lab.